Hello and welcome to today's lesson. To get access to our starter pack files such as blueprints, technical primer PDFs, native CAD files, as well as exclusive master courses, join our community on Patreon at patreon.com/ArielCad3D. You'll find the link in the description below. In this lesson, we're going to model the differential and rear axle housing, and that's also called the rear pumpkin. This is the feature that you see at the back of many vintage cars as well as heavy cars and lorries. So this housing has the differential gears as well as the rear axle inside. And the reason why I want us to design this first, to model this feature, is because before we install these friction dampers that we created in our previous tutorial at the front and at the back, they connect to the chassis as well as the rear axle housing and the front housing, the front axle that is. So we're going to design this feature first and then we will come back to detailing later on. So you start with a part design workbench, and I'm going to name this the differential housing, the differential and rear axle housing. And then I will create an axis system at the default center. So we want to start, let me show you another image. So we've got this housing shell and a cap here that is, closing it, and a cap on this side, and this is the differential shaft. So we want to start with this pumpkin area. It can be circular, or it can be in sort of an oval shape like what you're seeing in this case, but I'm thinking we can just go with the circular profile. So we will start by sketching one of the axes. Start with a circle with a diameter of 300 millimeters. So anytime you're adding the dimensions, make sure you check whether you're adding the diameter or the radius. So in this case, it's the diameter. And we're also going to create another concentric circle to represent the inner mouth rim. And this is going to be 250 millimeters. Like so. Exit the workbench and create a pad. We are going to mirror on both sides, and it's going to be 100 millimeters on each side. I'm going to give this a darker material, so that I can see my sketches better. Aluminum gray is fine. So we are starting with that basic shape. Then we are going to create that arm on one side using sketches and multi-section solids. Okay, I'm going to use this as our reference. Let me go to the front view. So this section here, which will be our upper side, you can sketch the ZY axis and select profile, create a basic profile. Perhaps I can start here first. Create a basic sketch like that, add some dimensions. So on this part, we've got a circular profile, and the radius is going to be 28, so that we have 56 at the end. Then the distance between this point to this axis is going to be 620. Like that. Now we want to add a corner here. You want to set, hold on. You want to set this line where you want it to be descending from. Okay, so about this length is okay. And you're going to select that point or that corner. We're going to add a corner of 200. millimeters. Then I'm going to adjust this. Let me zoom in so you can see. I need it to cut inside like that. So at a certain distance here, then we've got a slope. And what I'm going to do is I will delete this, or instead of deleting it, I can try to change, when I change, it moves the entire profile. What I'm going to do is I'm going to project this outer circle as a construction element. So make sure it's dotted. And then I'm going to use it to trim this element because I don't want it to project outside this feature twice. So instead, I will use a line. So where it ends here, just kind of connect it all the way to the center. The reason why I'm connecting it to the center is because I need a standard plane where both the top and the side profiles will originate from the same point, because we need to create two profiles at the beginning and at the end. So as I said, you can adjust this however you want your slope to be, but make sure that this point, the end point, coincides with this outer diameter. In fact, I think I will leave it like that at the moment. Exit. And then we'll sketch the side profile. So one that starts from the center, but at this point, it goes like that. We start by projecting this edge as a construction element. Like so. And then we'll create another similar profile. Like so. Again, we start by adding the dimensions. So we start with the radius, which is 28. And the length from the center, which is again 620. Then we add corner. Let's see, 150. And basically you want this line and this point to be coincident. And I don't want this, the curved part to be far away. I'm going to drag it close to this edge. And then I want to make sure that this line goes all the way to the center. Like that. Okay, we can work with that. So now we've got the upper profile and the side profile. We're going to mirror this, but because we were working with the part design workbench, you have to switch to this GSD workbench that I am in. I just clicked here, and you are going to mirror the profiles. Start with the top one using the XY plane, and the side one using the ZY plane. Next, we'll create the profiles at every edge. So we can have a plane. We can add a plane offset from this. This is ZX, offset from the ZX plane. And the dimension is 620. And we're going to create a circle . 56 millimeters in diameter. So it's going to touch all the 4 points. And we're going to have another one at this midsection, which is going to be rectangular. So this side and this side are symmetrical. And this side and the top one are also symmetrical about the horizontal axis. So you want to make this line and this point coincident. The same thing for this one. So that it's touching all the points. But then we don't want our profile to be very sharp, so we're going to add some corners. I will select all 4 corners. We will try 30 millimeters at first and see how that is going to work out. We can adjust later on if we are not happy with the results. So we've got these 4 sections, 4 profiles, I mean, the guidelines, the guide curves. We've got 2 sections, so we can use multi-section solids to join them. So back to the part design workbench, and we are in part body. We are going to select multi-section solid, select 2 profiles of the last 2 sketches. So because they are different, you can see we've got a closing point here and a closing point here. So that will not work because it's going to be very twisted. So you want them to be uniform. I'm going to replace this closing point with this point. Note that it's facing this side. And I'm going to replace this closing point again with the extremity in the Z axis, and make sure that they are all facing the same direction. This is very important. We're going to go to the guide curves, and you're going to select the 4 guide curves that you have just created. Then select coupling mode. this will not work. You're going to select ratio. So when you have two profiles that are very different, they don't have the same number of vertices, or you feel like tangency and curvature might not work, you can go with ratio. So ratio is going to try, and divide this circumference into equal parts, the same one with this one, and try to connect them in that manner. Preview. So if you have followed my instructions, you should have a profile that looks like this one. Select OK. Now obviously we need to do away with some of the sections. We can start by splitting using this initial face. I need to select the other direction. Then we're going to split. Again, the other direction. And then we're going to go to the GSD workbench, create an extrusion. Just sketch this ZY plane, or the plane that is normal to this face. And we want this internal edge, which was 250. So you're going to create a circle, which is 250, and make sure the center is at the origin so that they are concentric. And you're going to extrude a surface, both sides. Since we had 100, we can make it 110. Like that. Go back to the part design workbench. And again split using extrude 1. And you want the outer surface. You can hide extrude 1. So if your surface, you can also hide this sketch. This area might be different depending on, that curvature, because it wasn't very, very much standardized. So yours might appear slightly different, but just know it is fine. It is okay. So we've got this. Obviously, we will need to add some fillets. Now, the corner that we created is the one that governs how sharp these sections are. I also don't like how deeply this one goes inside. So you can come here to multi-section solid and you can edit the sketches. I believe this is sketch 3. I don't know. I feel like it's too much depressed on the inner side. Let me try to bring that out like that and fix the point. Then try to move this. Like that. Don't know if I'm making any sense, but let me try anyways. Again, you have this point and this line. Yeah, that's much better. That's much better. I didn't want it to be the corner to be too inwards. I wanted it to be like that. So as I said, you can control how sharp the corners are by controlling, was it the last sketch? Sketch 4. It's not sketch 4, it's sketch 5. Sketch 5, it's the order that is confusing me. You can control this dimension. If I make it 50, then our corners will stop being extremely sharp. I will go with 50. Now don't forget to save your work at every stage. So we're going to save this on our parts sections. It's the differential and rear axle housing, and save. Let me try to add, we might have to do variable fillets. But before we add the fillets, perhaps we should do the shell, because it's not a solid feature, it's a shell. I will select shell. I'm trying to think. Okay, let me add one more feature before we create the shell and see if that's okay. Go to the XY axis and sketch. And this point here, you can just select that curve, project it as a construction element, sorry, like that. Do the same for this circle. Go back to standard element, create a line that is connecting those two edge points. You want to zoom in here because you want to get the edge, like so. The reason why I've waited to shell is because I want to see if I can create this. It's sort of a stiffener, but you cannot use a stiffener for this feature. It works well on, you know, walls. So we will use a pad instead. Something like that. Zoom in to confirm once again. So we have that. And I will create a pad to imitate a neutral feature by selecting mirrored extent and the length to be 2 mm on each side. So you see, it's sort of a stiffener, but you have to use a different approach for it. Now I will try the shelling. Why does it look different on the inside? What's this? And it is not on the upper side. Why do we have a step here? This shouldn't be. This is not right. I'm not sure where this is coming from. Let me see the extrude. Was it sketch 6? Yeah, you can see this is not coincident with the center. So I'm going once again to create another one here. Make sure it's originating from the center. Still, I don't understand. We only have one axis system. I'm not sure why I'm getting this error. Let me try once again. Center. Pull it out like that. give it 250. And our render style is in, okay, this is strange. Let me check, let me inspect the first sketches that we made. Sketch 1, the two must be passing at the center. So this second one, I believe it's the one that is causing an error. Yeah, we have to be very careful. This is why you get a very annoying error that you, when you proceed with your design, it can be very hard to trace. So both are concentric. Yeah, we can edit sketch 3, no problem at all. Where is sketch 3? Actually, it's still fine, but I can delete that projection and make another one. And then select the new one, create the coincidence. Before I do that, I believe we still have, we might still have the prior coincidence constraints here. We should only have that one. Radius, tangency, tangency, offset, offset. Okay. And I want this to be like that. Oops, sorry. It's very sensitive to move. Let me move it with this line instead. Okay. So we've eliminated that problem. Well and good. I'm going to save to update it. Now I'm going to try the shell and I want to see if this stiffener is going to affect the shelling. If it's going to affect, we can undo it first. So you want to remove this face and this face, and you're going to select propagate faces to remove. Add 5 millimeters of inside thickness. Do not add external thickness. And select OK. Yeah, I knew this would bring an issue because it's trying to shell this stiffener as well, which I don't want it to shell the stiffener. So I can delete the pad, leave the sketch, leave sketch 7, start with thickness, same thing we just did. Five millimeters. So now you can see this is a mouth rim where the bolts and the nuts for the covers or the lids are going to go through, but inside we just got a shell. You see, it's hollow, and that's where the differential gears and the rotating axle is going to pass through. Now once I add this feature, I will need a surface on the inside to split it. So before I do that, I will go to the GSD workbench and extract this inner surface. I want just the tangency continuity, so that it's only going to select that surface for me. Tangency continuity. Let me see. Perfect. so that when I go back to our part body, I can create the pad, and then I can split using this surface, and I want the external one. So it's going to, I can hide it. Extract one, hide. So you can see we are still left with a smooth surface on the inside. So we've got sort of a stiffener. It only goes up to this material. So no need to mirror it at this point because we are going to split our geometry anyways. So we can create the ones at the top. Let me pull up the image once more. So we were adding this stiffener. It can go all the way to the end or some just slightly shy of the end, you see. Then we've got these two at the top, you see. So to make those, I can sketch on this plane, but first I need to create those curves. Hold on, why do we still have this geometry? What happened? What happened? Split one. That's strange. What happened? Was it because of split 4? Let me undo. I'm not sure what. Okay. I just want to hide extract 1. All right. Okay. I'll save my progress, and first I'm going to use this ZY plane to create 2 reference planes, or just one, because once again I'm going to split my feature. So I'm going to create a plane offset from ZY, offset from the ZY plane, this YZ, for only 4 millimeters. And then I'm going to go to the GSD workbench. I'm going to create an intersection between this new plane and split 4. You want to select split 4 because if you select individual bodies, it's going to select at different stages. But now we've got double the inner and outer, so I can split intersect 1 using the ZX plane, or using the XY plane, sorry. I need the upper side, and again I'm going to split it using this vertex. So now I only have the external curve. That is going to be the curve that we are going to use for the rib. Now we need to create the section for the rib. So I will insert an axis system here. Insert. This is not actually necessary. I just want it to be normal at this point. Select that point. So the x-axis, this x-axis, I'm going to create a line that, you know, it's tangent to curve, tangent to this curve at this point, like that. That's fine. Don't make it current. So deselect current. Select OK. I can hide the line. I don't need it. And then I'm going to sketch on this ZX plane. Create a simple, let's go to the other side. So create a simple rectangle like that. Make sure that these two sides, this line and this line, are symmetrical about the horizontal axis. So symmetry, give it a dimension of 4. That's not correct, sorry. Let me try on this side. 4 millimeters. So 2 on each side. And the distance between this axis, in short, how much it's protruding outwards, is also going to be 4 millimeters. Make sure this inner side doesn't, protrude too much. Try to bring it close to the vertical axis as much as possible, like that. So that's our profile. And if you go back to the part design workbench, you can create a rib. Our sketch is going to be our profile, and our center curve is going to be this plate. So they're supposed to be 2, but because we will split this feature in the middle, then I can just leave it like that. So you got the side, the top. I'm trying to wonder if I should have created edge fillet before I did that feature. I'm very sorry, but I'm going to undo that. Instead of undoing, I can just delete the rib. Add a fillet. And because I want a large fillet, let me clear that. Remove, I just need the edge. I want about, 100 millimeters. So I'm going to select variable, because 100 can only go so far. It cannot go towards the edges. For example, let me try, say 80. You can see the problem that we have. So instead, what I'm going to do is I'm going to select variable fillet, and I'm going to add points. For example, at this extreme, let me zoom in. At this extreme end, I'm going to have a 2 millimeter fillet. Okay. Then at this point, I can have about 50. At the center, I can have 100, or 80 is just fine. But let's say 100. Once again, at this section, I need 80. Sorry, that's 90, 80. And at the end, right here, it's 2. Didn't I change this one? This one is supposed to be 250, 100. Oh, this one is 50. 50. Let me try working with that first. So I'm trying to have this a wide fillet that converges at the end so that we don't have those ribbons extending towards the other sections. Let me see if that will work. There's a internal tangency discontinuity located. Not much of a problem. It just means that maybe we should adjust see this point. I can remove it and add it right there. The diameter is still 2. Come to the other side. Remove it from the edge and add it about here. Still getting some errors. I don't want to get any errors. I need this to work. So I can move my 50 point. This point. Come on. This point. Let me pull it up. Remove that point and move it up here. Or even create a point close to this, close to the 100 one, and make it 80. Then have a small point here and only make it about 20. Let's do the same for the other side. Point here 20 and point here with 80. Much better convergency. So you can see a variable fillet. You're going to do the same for the lower side. So we've said a variable fillet. At the center, we've got 100. Then we're going to add some points. At this section, we are going to have 80. Another 80 right here. And that's fine. Then we're going to have a 20 right here. And close to the edge, we are going to have a 2 millimeter. So we've said this one is about here, and it is 20. And close to the edge, we've got a 2. Remember, this will probably be done by filing. Okay, that's why it's variable. Beautiful. So we're going to edit intersect 1. Because now we need it to cover the edge fillet. So I don't know, perhaps clear this. Then we can try, let me see. We can try to create an extract. extract in tangency of this section. And split 1 is going to be this curve. Element to cut is intersect 2. We can delete split 2 because we don't need it now. We can use split 1 as our center curve. And we have sketch 8. I hope it's not going to show update error like our cycle update. But let's try. Let's see a rib using sketch 8 and split 1. Yeah, I think that's okay. So it has updated this curvature. That's fine. So now we can split it and mirror our images. So simply select split. Splitting element, we'll start with the ZX so that we have that half. Now we want the upper half. So again, we will split using the XY plane. Remain with the upper half. I still need to split again. Split. Hide this, by the way, using the ZY plane. What just happened? Split using, the ZY. So we only have this quarter, and we can now mirror this using the same process we just did with splitting. We are going to repeat so that it's sort of identical. Again, we are going to mirror. Now I want to start with the XY. Perfect. Okay, in our next lesson, we are going to create that end part. You see this part, and it is sort of inclined to match the wheel at 3 degrees. So we will create that part and then complete mirroring to the other side and continue creating the curb and the differential shaft. So I will see you in the next lesson.